So I'll start then. It's not 18 people who it's quite nice. Okay. So many of you don't know me. I guess only 2 or 3 know me. I'm Shivam. I'm working as a QA for the very famous NEAR project. I have total 5+ years of experience in load and performance testing. And I thought Engineering Summit is a good platform for me to share my performance testing knowledge and the work that we have done in the NEAR project in the load and performance testing area. So let's start. So I'm also going to start my presentation with a why, same as Florian did yesterday. So why load and performance testing is important. So firstly, when we are doing load testing, it simulates real user scenarios. So when you are testing your application or your service under load, then you are actually checking how your application or service will behave when 100 or millions of users will access your service or your application. So when you are doing functional testing or single user testing, then your application might behave completely different as to when it will behave during the load. So to understand, analyze and fix errors and performance bottlenecks, it's very important that we do load testing. Secondly, your system performs differently under load. So most of the KPIs like response time, CPU utilization, memory usage, and memory leaks or garbage collection, GC pauses might look top notch when you're doing single user test, which is functional test, and could suddenly plummet when your application is put under some load. So you should know when and where your application breaks and fix it to avoid upset users and revenue loss. Thirdly, your code can change your product in unexpected ways. So even a small change can affect your service or your application. So it's very important that we run a load test before making a change so that we have a baseline, and after making that change so that we know the impact of the change that you made and compare it with the baseline. Fourth, users are very brutal. So if during Black Friday, Amazon is down, users go onto Twitter and they write angry tweets against Amazon and condemn them for not being able to avoid this crash. So instead of investing in PR managers and rebranding, we should do proper load test. And users have a very good memory, they would not like to revisit an application which was down or which was performing badly. Second, incidents at eGEM. So I was told that majority of the incidents at eGEM are related to performance issues. Nikki would be knowing that. So if we have a good load testing approach, then we could avoid majority of those issues. Next, moving on to the performance testing roadmap. So do we have any product owners here? Okay, so this is basically for them. So if there is a new project coming at eGEM or there is an existing project which doesn't have load testing implemented, so where and how a person should implement load testing into its project? Where he should start? So there are certain steps to it. So firstly, identifying the performance testing environment. So it says identify the hardware, software, network configuration and tools available for performance testing. Yep. So coming back to the very hot topic of staging environment, which we were discussing yesterday. So it's very important that the performance testing is done on an environment which is replica of production environment. But it's not always possible. Maybe. Yeah. So I was saying it's very important that the performance testing environment is a replica of production environment, but it's not always possible. Maybe product owner is not agreeing due to budget issues or whatsoever. So, but we should try to match the OS and the settings, the applications which are running on the performance testing environment, or the hardware components and the database. So you can't have in your production is running with 32 CPUs and you run your performance testing on a system with 2 CPUs and everything runs fine. So you can say, okay, everything will run fine on production. It doesn't happen like that. So it should be comparable to the production environment. Secondly, identify performance metrics. So this provides the success criteria for performance testing. This is basically, we get this generally from the product owner, and the major metrics that we have in performance testing are the response time and the maximum throughput that your application can handle under load. Thirdly, planning and designing the performance test. So it says identify performance testing scenarios that take into account data variance, target matrix, and load profile. So I'll give you an example. Different applications require different kind of planning and designing. So if you are load testing one application, that might require data to be already set up before we run the load test. Some applications might require that you set up the data as part of the load test. So you should have a data setup phase before the load test, and then you do the actual load test. And some applications might require data to be cached. So there would be 3 steps to your load test. First would be the data setup, in which you set up the data. Second would be you access that data so that the data gets cached. And third would be then you actually bombard the application with load. Fourth, configuring the test environment. Says prepare the elements of test environment and instruments needed to monitor resources. So you might need certain tools or applications to be configured to the test environment. For example, you would like to install some profiling tools or maybe Grafana to display the dashboards. So you should configure your test environment with those tools. Then the final 2 steps would be execution and the analysis. So in addition to running the test, you should monitor and capture the data generated. It's not like you kick off the performance test and you sit back and relax. You should also monitor your load test during execution and look for any performance bottlenecks, because it's easier to triage a performance issue during runtime than after the load test. And analyze the data and share the findings with the developers that develop that application, and fix the performance bottlenecks and retest. Then this is nothing but a pictorial depiction of what I talked about in the previous slide. So what components you exactly need before running a performance test? These are the prerequisites. The first point is the SLOs. We discussed quite a lot about SLOs during Mickey's keynote. And second is the design load, that what exactly load you want to put onto the application which should be comparable as to production. So these are generally the responsibilities of the product owner. Then there are certain responsibilities of a QA or a dev guy, which is setting up the test environment, we already talked about, setting up the test data, and request cocktail. By request cocktail, it means that it just means that the data variance, you should not just sequentially load your application. The request should be done randomly as it would be in the real world. And then then you do the performance test, and what actually you get as a result of the performance test. So these 2 are the major things that we look after the performance test, which is the maximum throughput that your application can handle under load. And then is the latency. Latency means the response time of your service or your application or a particular flow that you are performance testing. And next comes the resilience. This topic I'll also explain in the upcoming slides, but it just means that checking the capability of our application to come back to its initial state from a very stressful state. I'll explain that in the upcoming slides. Then we move on to types of performance testing. There are multiple types of performance testing, but these 3 are the major ones that we do. So it's load testing, stress testing, and endurance testing. I'll explain each one of them with this graphical depiction. I've copied this graph from a presentation that I gave in my previous company. I was working for a banking client, and it shows data from a bank's customer support application. So if you see at 8 p.m., the bank customer support guy starts to log in into the application, and slowly and gradually the load increases. At 11:30 we have the maximum load, and this data is from their busiest day in a year. And after that there is a dip in the load to the application. I don't know why, maybe lunchtime. And then there's again a peak, and then at 6 p.m. they all go home and there's no load on the application. So this is the point of peak load to the application. So when we are running a load test, we'll bombard the application with this load. So for example, say it was 500 requests per second. So we'll run our load test for 500 requests per second and see how the application is behaving under that load. Next, I'll come on to the endurance test. I'll explain stress testing at the end. So endurance test is done at 80% of the peak load. So if the peak load was 500 requests per second, so we'll run the endurance test at 400 requests per second. But the only difference would be we'll run the endurance test for a long duration of time. So ideally the endurance test is run for 7 to 8 hours, and after the test we check for any memory leaks or long GC pauses that we might have had on in the environment. And then we come back to stress testing. So consider if there is a Brexit kind scenario and the bank is forced to hire some more customer support guys and the load onto the application increases. So suddenly what they'll see is the trend shifts from here to this dotted line. And the peak load point will shift from here to here. But this point is also unknown to the product owner. So this is not predictable what this point will be. So we'll do stress testing in this scenario. We'll load the application till the point the application breaks, so that we have a breaking point of the application. So we could say that okay, the application is not able to handle load beyond this point. So these are basically the types of performance testing that we do, the major types. There's also scalability testing that I talk in the upcoming slides. So now we have also done some load testing work in the NEAR project, and here are some features of that load test that we did.
We are stress testing this room for it's gonna burst.
So like most of my performance testing experience was in a tool called HP Load Runner. But when I joined EGM, I was told that we do not use any tools. It was a cultural shock for me. So I was told that we do not use any tools here and I have to develop my own tool. And don't kill me for this, I did not know any programming language until then. So I started with learning Golang. I had two options, Python and Golang. But I don't know who told me that Golang is a better option. Maybe it was Robert. So why did we choose Golang for a load test? So as part of NEAR, we are testing gRPC services. It was also quite a hot topic this afternoon. And so it was told to me that gRPC are best suited with Golang. So we went with Golang. And I just knew Golang, so that's the main reason. So now our load test has different phases, which is the data setup phase, warm-up phase, and the actual load. So what we do in the data setup phase, we just fire the data. We just fire the load test to create the data. We are not measuring any metrics in this state. So we are just creating the data for a load test. Second phase is the warm-up phase. In this phase, we are caching the data because this is the real-world behavior of our server gym service, which we are testing as part of NEAR. So data would already be cached. So in this phase, we cache the data, and in the final stage, we bombard the service with actual load. Third, our load test is completely randomized. The calls, the requests that we are making to the methods are completely randomized because like this is what will happen in the real world. Not all users will do the create request, not all users will do the get request, something like this. So we have a mix of calls. And also NFRs for different methods are different. So we have randomized it with a relative frequency. Then we move on to concurrency. Our load test is concurrent and we are using Go routines, which is a feature of Golang. So we have configurable number of clients that we run, which could go as low as 1. And when the load test is over, the metrics around the across the clients are summed up and then are displayed. Then determining maximum throughput, this is nothing but the stress test. So in this step, in this case, we are slowly and gradually ramping up the virtual clients and loading our application, and we stop at the point when we see the throughput is stable and not increasing beyond a certain point, or if we see the number of errors or the percentage of errors increases beyond say 2%. So this is basically done to check how much maximum load our service can handle. Next is the configurable load profile. So like what this does is we can give the design load. For example, today we are running 300 requests per second, and then later on we want to run it 500 requests per second. So we can give the design load as part of running the load test. So we give it as a command line argument, and the throttling of the request is being done automatically by inserting variable think time between the requests. So if we say that we want to run a test at 400 requests per second, then our load test is able to automatically calculate the think time or the pacing that it needs to put between the requests. And if later on we say we want to run for 1000 requests per second, it will reduce the pacing or the think time between the requests. And our load test is completely Dockerized and is running in Kubernetes using help charts. Next, we move on to some dashboards from our load test. So if you see on the left hand side, this is from Grafana. So if you see, as part of load test, we were testing two methods, update method and the get method, and this shows the 95th percentile response time for both these methods. And on the right side, you will see the throughput that we were able to put onto our application. So this is multiple load test instances that we ran that day. So if you see, this tells us that this is around like 180 or 185 requests per second that we were able to achieve. Next, we move on to common performance testing mistakes. So first of which is not enough time for testing, because sometimes we have shorter sprints or we have shortage of time, so we do not put much emphasis on testing, and especially performance testing. And second point is not involving developers. This can't be the case at eGym because majority of the people are developers and there are hardly any QA guys. So I hope this changes down the line. Third, not using QA systems similar to production system. This brings us back to that topic again of staging environment. So it's very important that we are running performance tests in an environment which is a replica of production environment and not just any random environment. Second, there are certain myths related to performance testing. One of which is a full load test tells everything. So it's not like that we have run a load test and it runs fine, you get very good metrics and you say, okay, the application will run fine in production. So you should run multiple kind of performance tests, which is stress test, endurance test, and there's also scalability and resilience test, which I talked about in the upcoming slides. And this last myth, please don't kill me for this, software developers are too experienced to need performance testing. Sorry. So, see, performance issues are not related to experience. So, there might be cases when some developers which have produced issue-free system or services in the past can also make mistakes. So, because the thing is like multiple factors come into play when there is load onto the environment, which are not predictable, which cannot be assumed. So it's very important that we do load testing and we rest assured that your application will run fine in production. Next, we come on to the to-do list in the near project, which will be in the near future. So one is the endurance test. So we have planned to run a test for a duration of 1 week. We'll just keep it running, and we'll just, after the test, we'll see if there are any memory leaks or long GC pauses. We'll also look for any errors that we get during the test and investigate them. Ideally, we should not see any errors, but if we see, we'll surely investigate them. Next is the scalability test. So what we'll do in this test is, we'll run our test to determine maximum throughput, which we already have as part of stress test. But in this kind of test, we'll, so for example, we are running a test on n nodes. Then what we'll do is we'll now scale up our environment to n plus 2 nodes and then check the maximum throughput. So we'll keep on increasing the number of nodes and see the pattern. So hopefully we'll get an interesting pattern to investigate. And next is the resilience test. So I'll explain resilience test in my next slide. Okay, scary. So in this type of test, what we'll do is we'll run our normal load test at design load, which is say 300 requests per second. If few minutes into the test, you can see the latency is going at this rate, say 20 milliseconds, and there are no such errors that we observe. But few minutes into the test, we'll put some extra load onto our application, which will be more than the maximum load. How we'll achieve this extra load is fortunately gRPC has a feature of putting asynchronous calls, using asynchronous calls, right, Nikki? So we'll put some asynchronous load onto the system and we'll overload the system. So at this point, ideally what we should see is latency should increase and the pattern would go like this, and the number of errors will start to ramp up. At this point, we'll remove the extra load, but system will take some time to recover. That is what we assume and what happens in the real world. So if you see, after we have taken out the load, the latency will take some time to return back to its normal state, which is the initial state, and the errors also will start to go down as the system starts to recover. And this part is the recovery state of the application, which is known as the resilience. So if this is more, then there is a problem in the application. This should be as less as possible. So this is what we are going to do as part of resilience test. Anything else I could think of? Oh, no. Yeah. So my very short presentation comes to an end. Thank you, everyone. Any questions?
What was the deal with not using the tool?
Not using the tool.
I can explain this. So, I think Shivam has a lot of very correct like reactions to things where he says like, no, I am too lazy for this shit. Can we not like find something that does it for me? Like for example, when we measure it, the idea that we could produce the load, but we use the metrics that are built of the application to measure the results of the performance test, right? So you don't have to actually do all of this work. So they're good ideas. But when we started, I also wanted to make sure that Shivam has enough exposure to programming to get the tools done. So I make him rewrite everything he could possibly use. That's why he's not allowed to use the tool.
Okay, so I thought it's due to the licensing cost.
Yeah.
Now I know. Any more questions?
Yeah, I have a general question about load and errors. Why do actually more errors happen when there is more load on the system? Because why is it not just slowing down the system and increasing latency? Just in general, I'm trying to...
Okay, so when you increase load onto your application, then the latency increases. But system also has its threshold. Like you cannot load your application beyond a certain percentage. So if you're, I'll go back to slides. Okay, so if you load your application to a certain extent, it will start to perform badly. We'll see high latency, high response times. But beyond a certain percentage, if you max out your system resources, they are not able to serve any requests. Then at that point, you'll start to see failures. And you will see those failures until and unless the system recovers back to its initial state.
So an error is like a connection timeout?
Yeah.
Okay, yeah, makes sense.
Out of threads or something.
So what system did you, so we have no staging environment yet? So what was the system you used?
So we have test environment for Neo. So we are doing load testing in that environment.
So it doesn't need to be ported to a more production.
Production-like environment. It's still a functional testing kind of environment, and we need to move on to a load testing kind of environment to run our performance test.
I think the staging environment comes in if we want to do something like this on something bigger, right, with more services attached.
Correct. Yep.
Based on the results of the recent tests, what types of problems did you find in the code? So what's the result of these tests? What kind of problems did you find with the code? Like just generic types?
Okay. To be honest, we have not found much issues so far as part of our load test, but we are yet to do endurance test and the scalability test, and I think we should definitely catch some of the issues that we have in our current setup. Or maybe if Robert is able to think of any issues that we found.
I think in the very beginning we found like functional issues that of course should have been caught before we do endurance or some sort of load testing, but yeah.
So you didn't go full stress test yet?
Earlier, it's still planned.
And the recovery time reveals something.
The resilience test is what we are looking forward to.
Maybe I should rephrase the question. What kind of programming errors are you hoping to find?
Programming error?
Yeah, in the code, so something that can be fixed.
Okay, so as part of performance test, we'll be able to check if we are getting high latency and we are getting out of system resources, and then we report this stuff to our developers and they are able to investigate more on this and find any performance issues or issues with the code.
Basically, a load test is supposed to find bottlenecks, right?
Performance bottlenecks, yeah, correct.
Maybe to quickly add to this, you might run into things like if you have a connection port to the database, it might simply be too small, too large, what have you. So you might run into congestion there, or you might have a mutex somewhere that just works fine most of the time, but if too many Go routines or threads or whatever try to lock it at the same time, then the time overhead to lock this thing might actually be the bottleneck. If it's
Indexing issues or whatever database.
or indexes, yeah. Or actually the paging in the database might be that the working set no longer fits in memory, and then it has to load a lot of stuff from disk, and suddenly it gets 2 orders of magnitude slower.
I think
We
you
have a
can-
performance test that we did with Each and Visa. In production, it turned out that the database storage engine that we're using locks the entire collection for every write, which was unideal for our use case. So,
Also some configuration problems before
Yeah.
that.
Like,
So-
even if we don't find any problems, if we, let's say we're running our service at 1,000 requests a second and it works fine, then somehow our PO should know whether this is the top limit of what we can ever do in our lives, or whether there's like headroom, right?
Plus for a service like Nearwrite, it's very important to handle the load that is already expected to be coming. It's very different to,
Right.
For example, the
yes, if you have a new
quality
service that
gradually
slowly
starts.
ramps up, then
Yeah.
I think you have a little bit, yeah.
You have
Okay,
very
yes, so I think that makes perfect sense because you're positively scared shitless about the fact
yeah.
that you flip the switch in one with the Galaxy,
And
and then
then,
it just dies. And then you go back and do 3 more months of work to rewrite it.
Yeah.
And then it will be bad.
And Robert, did we not find an issue when we were running multiple
I
concurrent
was thinking
clients for the
about this.
code?
We did
Yeah.
find some issues.
We
but I
did
can't
find some
piece it
issues.
together
It
anymore.
was
There
long
some
back, maybe the
gRPC
initial.
spreading something.
I have a question. Because you reach a number of the total load the system handles.
Yeah.
How can we ensure that it's not a limitation of the test, but it's actually a service limitation?
Sorry?
Because the test can also reach its limit of the request it can make. How can we ensure that the limitation of the request number is not the test, but is actually the service?
So this thing we need to take care when we are planning and designing the load test. We should ensure that this problem doesn't happen as when we are designing a load test. So we take care of this issue when we are designing a load test. So yes,
What things can we pay attention not to fall into the bottlenecks of the test?
bottlenecks of the test. You should write your load test properly, like me. Yeah.
Why do you think you need a special load testing environment or staging environment? Why can't we just spin up everything with Helm charts when we need it and then tear it back down?
So this is what we are planning down the line. Like you have a similar setup for UPDS, which auto sets up the
I'm not
environment.
using Helm yet, but
You're not using
yeah.
Helm?
Not using Helm yet, but it spins up.
Shivam's plan was entirely to steal all your shit and use it for his, and now he's finding out that he's not using it. It looks like that.
But essentially it spins up an entire UPDS environment, including a new database, and then bombards with requests for some time. Of course, not anything close as sophisticated as what you're doing, but yeah, the basic setup is there, and then it tears everything down again. So you get a fresh database, fresh environment, and everything.
This is what we have in the pipeline. I already stole your code. So the next step is to have a session with you and understand how this works and implement same in the near project.
Yeah. And maybe we can rewrite it to use Helm because
Yes, please. That's it then. Thank you, everyone. Thank you. I should have brought a gun like Chifko.
So one more final question from me. What kind of metrics are you recording during this load test? Are you enabling any like debug metrics, for example, for generating flame graphs or something like that?
So the major metrics that we get as part of a performance test are latency, which is the response time. So if our SLO says that 99% response time should be less than 100 milliseconds, so we have configured our load test to output that metrics at the end of the test.